Hello, I'm Paul Hutton, editor of Smart Highways magazine. We're just getting ready to show you another session from JCT Traffic Signals Symposium 2018. But before, let me just remind you of a few things. First of all, if you're at JCT this year or are affiliated to the organisation, you can sign up for a free copy of Smart Highways magazine. Just go to the link at the bottom of the screen. Also, mark your cards for the ITS UK Summit, 26th and 27th of November at the Bristol Harbour Hotel. It will be a fantastic day talking about implementation. And next year, don't forget, Trafex, 2nd to 4th of April. It is the biggest and best Trafex yet. Don't miss it.
Now, late addition to the papers, but I was desperate to get her on when she offered this as a paper. In fact, Dan Priest put me onto it because, as we know that Jackie Davies has contributed to the symposium before, and really we've watched her experience grow. We've grown with her at the symposium. But get to the point now where she's basically principal UTMC engineer at Bristol. She basically runs Bristol's traffic control services. She manages the UTC Scoot and all of the ITS, and she's also responsible for delivering Smart City and open data initiative. She's a very, very busy lady, and she's going to deliver a paper for us today called, this will chime with the audience well, Doing More for a Lot Less, Effective Cost-Saving Measures in Urban Traffic Control. So there'll be some ears pricking up at that, with money being as it is.
Thank you. Okay. I've had an awful lot of conversations recently with many different local authorities, and everybody is saying the same thing, which is this. We've got traffic increasing year on year. We don't seem to be increasing road space. We've got massive political pressure, political visits to the control rooms, front page newspaper articles. There are lots of solutions that exist in terms of ITS and UTC and so on. But our revenue budgets are shrinking. So we have got less in terms of revenue budget, but we're maintaining more. We're trying to deliver more. And it's really, really difficult. The maintenance of infrastructure seems to be a huge challenge that everyone in the industry is talking about. So there's lots of solutions that we're all using, sharing infrastructure, putting in our own fibre, those sorts of things. But I'm a Scoot specialist, so I'm going to focus in on reduced detection, because I think one of the biggest challenges that we have in the world of UTC and Scoot is maintaining our detectors. So if you don't use Scoot, you can have a nap for 20 minutes. Before I start talking about all the reduced detection techniques that we can use, I'd like to just cover off how a loop is meant to be set up and working. And that way you can look at what you can do if you haven't got the ideal. So a detector is normally cut 2 meters in direction of travel, so you've got a detection zone of about 2.5 meters. It's normally cut just beyond the end of the normal queue. What you want is for traffic to queue back onto the detector only during the height of peak. The rest of the time, the traffic should be able to flow over the detector so that the model can find platoon arrival to do its offsets. You want to cut it in about 1 meter from the center line so that you're not getting clipping from the other side of the road. And you don't want traffic sinks or sources, so you don't want side roads after the detector that are causing traffic to be lost or gained. And that's pretty much it with sighting Scoot detectors, to be honest. So how do they actually work? What do we actually need from them? In terms of traffic flow and discharge across the stop line, it's quite straightforward. The detector's polled 4 times a second every second, and it sends back a stream of data in the form of ones and zeros back to the UTC system. It sends back link profile units. It's not a car count, it's just link profile units. It works out about 17 per vehicle usually, but it doesn't really matter. We're working in link profile units. We then calculate a discharge rate across the stop line in link profile units per second, so you count it in, model it out. And as long as you've got that value correct, which is called a stock value, those link profile unit value, then it'll model right. You'll discharge your traffic. So that's it really in terms of traffic flow. There's a couple of other features that it also needs to be able to do. One is to measure congestion. So when traffic is queued over the detector during green and it's not moving off, that counts as congestion. I think the Scoot measure is 4 seconds of continuous detector presence during green, not counting the first 4 seconds of green, expressed as a percentage. But essentially, it's an actual mathematical figure. And because it's a proper number, then you enter a congestion importance factor that acts as a multiplier against that value. So essentially, the way the model works is a little bit flawed. The model will always try to give the same degree of saturation to every single junction approach, but you almost never want that. You want the model to bias towards the main roads when it's busy and let traffic queue on the less important side roads. So when you're trying to achieve that, you need to be able to measure congestion, which is why you need that upstream loop in the right place with traffic queuing over it only during the height of peak. The other thing you need is offset optimization. This is the really key part with Scoot about how you get those extra benefits out of the system. So the model is looking for platoon arrival. As the traffic from the upstream junction discharges, the traffic comes down in a great big clump, and the model looks for that arrival of platoon. It uses that to find when to go green at the downstream stop line and create an offset. So it's really important that, again, you have that upstream detector so you can work your offsets properly. Right, but we don't live in a perfect world where we all have the budget to put in perfect detection in exactly the right place all of the time. And we certainly don't live in a world where once we've got it in the ground, we can afford to maintain it. So what I've done here is I've just collected together all of the alternatives that I have used and how I've made them work. Just stuff that we've tested and used in Bristol over the years. I hope it's of help to some of you. Nothing here is particularly new or groundbreaking, but hopefully it'll be of some help. So if I haven't got a Scoot detector, a normal upstream Scoot detector, I want to find an alternative. Can I use an SD or SA loop that is already in the configuration, already cut? All I need to do is just pick it up as a Scoot loop and use it. To do that's quite straightforward. You either have to change your configuration, or if you've got a Siemens controller, you can just IOA the input across, and you just literally map it logically across. I've also used move-it-in detectors for this as Scoot loops. The detection zones are slightly different, but it doesn't really matter. You just adjust your stock value. If you're seeing a different number of link profile units coming in on the loop, you just have to model them out. It's quite straightforward. If you're using an SD or SA detector or a move-it-in detector, it's cut in roughly the right place upstream of the junction. So it's going to be able to model congestion, offsets. It'll pretty much do everything you want. That's my first choice. Junction 2 of the M32 in Bristol, we're using the SDE loops because the cost of traffic management to recut the Scoot there was just prohibitive. There we go. Right. After that, then you're into other features of Scoot, historic detection. These are loops that are cut at or downstream of the stop line. So because it's cut downstream, you can't model congestion. So you've got to be a bit careful of that. And in order for it to work, you've got to have a really consistent journey time between the detector and the stop line. If you don't have that, then, so if you're exit blocking, issues like that, a filter won't work. We had a lot of sites in the city centre recently due to very long-running roadworks where we couldn't recut detectors, and we switched and used the downstream detector instead of using the regular normal loop because it was cut through. And it worked quite well, but only where you don't have exit blocking. It can't model congestion. That's the big problem with this. But they found a way to mimic it. So again, you want the model to bias towards your busier approaches. So if you're trying to use a filter link on a busy approach, you've got to make sure that it will bias towards that during busy times. But within the Scoot system, they've created this feature called filter saturation and filter multiplier. And you just tell the model, when the filter saturation level gets to this point, I want you to start biasing towards it. It competes with the congestion importance factor and means you can use filters on main roads. But you can't model offsets with a filter. It just doesn't work. So it depends on what you need to do and what situation you're in, but that is a viable option. Stop line detection is the next thing on my list. I like this slightly less than filters because there is absolutely no way to model congestion, and oddly, there is no alternative. So it's a bit strange because with filters, you've got the filter multiplier option, but you don't with this. So I'm not quite sure why that got missed, but there we are. However, oddly enough, there is a function that lets you model offsets. So if you're looking for a form of detection on a side road, for example, this would probably be reasonable. I haven't had a lot of success with the modelling of offsets on this, to be honest with you. But the good thing about this is it doesn't have to be a Scoot stop line. You can use, I've used Z loops, the system DZ loops, and I've used just regular stop lines that, for VA. So, and mover stop lines. It doesn't matter what it is. If the detection zone is slightly different, again, you just adjust your stock value. So that's something that we've done where we've needed to. The next thing, I'm starting to scrape the barrel a bit here, short link detection. This is things like your mover X detectors or a VA X detector. They're very close to the stop line, which means you've got a really short link. If you're using a VA X loop, it's about 5 seconds. The Scoot book recommends a minimum journey time of 6 seconds, so you're pushing the limits a little bit here. But X detectors still can work. You have to do a bit of adjustment to make these work because this is a bit more of a fiddle, but you've got a fairly large detection zone, so again, you just adjust your stop value, no problem. They are normal links, but because they're so short, they're always going to show high congestion. You're always going to have a queue back onto that detector. So you just need to drop your congestion importance factor down really low so the model isn't constantly biasing towards that approach when it doesn't need to. So again, it's fairly straightforward. The other thing you will struggle with is modelling offsets. Because the model will never see that nice tidy platoon arrival because there's constantly a queue over the detector, you have to put a default offset and bias in. So you just manually set the offset to what you need it to be. And that does work. This is when you're really struggling. It's not something that I would recommend particularly, but it's something that I have used in certain locations where there's really been no other option. After that, you then get into the actual Scoot reduced detection techniques. There's 2 of them, and again, they both work reasonably well. So reduced detector proxy link, I really like this. I think this works really well. It allows you to use an upstream detector at a junction downstream. So the Scoot model knows what's going on between the detector and the stop line, and all you do is you tell it you're going to use that loop at this stop line down here. And all you do is you enter a journey time from the stop line to the stop line, and then you just need to tell the model what proportion of traffic do you lose after the detector and how much traffic do you gain after the detector. And that's pretty much it. I've explained the maths in the book, in the information, but I didn't bother to put the formulas there. It looks a lot more complicated than it is, but that's pretty much it to set that up. It's really straightforward. And it does work really well. You do get some really good results. One of our busiest areas in the city centre, we ran on that, and we got some really good results from it. We ran it for about a year during a major roadwork scheme. The other form of reduced detection that you can do is reduced detector proxy flow. That's where you just literally enter a traffic flow value in an hourly rate into the model, and the model will just assume a certain level of saturation based on the value you enter. You can timetable it by time of day. So if you've got a quiet side road where the flows are fairly consistent, or you know when they're going to increase and you can timetable it, it's absolutely fine. It works really well. I've used it quite well on minor roads, but you've got to have that consistent traffic flow because it's never going to adjust for that. And the only other thing I've done is not used any detection at all. I've got a park and ride exit with one bus every 10 minutes. I'm never going to need to run more than a minimum. So why would you bother to put a detector in? So sometimes not using any detector is fine. If you've got a very consistent situation, that might be an option. So those are the few techniques that we've used in Bristol when we've had problems and we've needed to plug the gaps. I hope that that's of some help to some of you, as I know we're all facing this budgetary challenge. So thank you very much for listening, and any questions?
Thanks, Jackie. Told you it'd be worth waiting for. Questions? Got to be some questions on this. Yeah? Well, I have. I've got loads. Back in the day when I was doing Scoot training, I was doing mover training, we were always told how important it was to get loops accurately cut in the right place. The mover loops have got to be at exactly 3.5 seconds and 8 seconds cruise time from the stop line, etc. Now we already know, because Dan's basically been making mover work on a bit of washing line and things like that, haven't you? By the sounds of it, you're getting Scoot to the same. Is it literally just a case of then adjusting the factors in order to get the right LPUs?
Exactly. You just manipulate the parameters to make it work. You'll get the best results if you set your loops up right, and that's what we all aim for. But ultimately, we live in the real world. If you've got a major roadwork that's going to take 18 months and they start chopping through loops on day one, and you want to keep that running on Scoot for as long as you can, what alternatives are there? And just run through them.
Dave, are you sort of a fan of this? Have you been?
Same as Jackie, where we've got mover, and if we put a mover site in, we'll automatically output it to Scoot, the in detectors, the 8-second journey time. It then gives you the option to put UTC Scoot on as well as mover. So yeah, we've done that, and same as Jackie, we've got loops where we've got high-speed roads, we call it SATOC, so we'll change the SATOC because obviously as it's going, instead of going over at 30 mile an hour, they're going over at 40. So although you're giving a different value because it don't seem the nibbit same.
Yeah.
But yeah, it's. I take a point with stop lines though. Stop lines, it's the very, very last option that.
Yeah. Yeah, you can, as long as you put every single loop you might ever want to use in your configuration, you can pick it up at any point and start using it really easily. But if you've got traffic management on a motorway off-slip, changing a config is cheaper than that's ever going to be. So it just gives you options.
So if you were going to use something like I'll come to you in a sec, Mark. If you're going to use something like a stop line loop, I presume you couldn't use a stop line loop to be basically a detector for a downstream junction, though, could you? Because it's behind the stop line.
You can use stop line.
So it will not work with the model, would it, or would it?
There's a feature in Scoop for modelling off stop line loops, and but it doesn't model congestion, and there's no alternative to the filter saturation, so you can't get it to bias. When it's busy, the model will always go to the congested links and give the green to those. So it really only works on side roads. There is a feature for modelling offsets, but I don't think it works very well. So
if you can make it work, if you can make it work with all these various loops, I mean, what about non-embedded loop detection? I mean, what about, is there any place for magnetometers in this or video detection?
I'll use anything. I've used mover loops, VA loops, I've used all sorts. I even played around with an MVD. That was not successful, but I wouldn't mind trialing one of the 318s though. But yeah, anything. We've had cabled mags, wireless mags, overhead detectors. We've trialed all sorts, and all that matters is that you get your model set up to manipulate whatever parameter it is that you need to tweak.
A lot of it's about the validation, then the calibration.
Definitely, yeah.
Thanks, Mark.
Mark Plato, PTT, Jackie. Right at the bottom end of that, you were looking at proxy flow values, suggesting a fixed hourly flow rate. Is there any potential to load different time of day flow values to give some sort of profiling onto that proxy data?
Oh, absolutely. You timetable in a value, and it just changes for each peak or whenever. You might have a rush of traffic half an hour before the schools, kick out or something, and you just timetable it in. But because it's still Scoot, the model will always say it's running at 85%. It will always run at that point, but it will still be Scoot. So if another approach is more important, it will nick time from there and give it to the side road. So it's sort of a weird hybrid between a fixed time plan and Scoot.
Okay, thanks.
Fabulous. Any more before we release Jackie? Dan?
Just a quick point.
Just wait for the mic, Dan. We're recording.
Hi, Dan Priest, Integrated Traffic Services. It's only a real quick point about the in-loop and Scoot. I mean, on a lot of the jobs that I'm designing now, a lot of them are in Scoot regions, but even the ones that kind of aren't, I'll tend to be speccing the in-loop to be cut as a Scoot loop, just because then you can use it as a profiling loop, like an RTM detector or something. It really makes so little difference to move a cutting it as a Scoot loop. It's just not. I know you can get them working by manipulating the profiles, but my advice to people would be just cut the in-loop as a Scoot.
Okay, thanks for that. Okay, thank you very much, Jackie, and thanks for stepping up at the last minute.